This is Uganda Online Lessons, and I'm Sanja Shakif. Please don't forget to like and subscribe to both YouTube and our Facebook channels. And we need your feedbacks as well. Today we are gonna discuss on ratios, proportions, and variations of mathematics O level. The ratios, proportions, and variations. So at first we are gonna look at proportions only. So it will come here on ratios, non-proportions. So ratios enable us to compare two or more quantities of the same kind that are expressed in the same units. So at that we shall look at what we call also rates, where these rates enable us to compare two quantities of different kinds. So let's try to look at one example from rates. Which is if the athlete runs 12 kilometers in 48 minutes. So we say that an athlete runs at a rate of 12 kilometers over 48 minutes, becoming a quarter kilometer quarter kilometer per minute. So this kind of rate is what we call speed. This one is the one what we call speed, meaning that it's a total distance covered per unit time. So let's try to describe what is a ratio also is. So there is an example. Concerning ratios, so suppose 2 packets of Omo contain 2/3 kilograms and 60 grams respectively. So the ratio of these two packets, it will be larger to smaller, meaning that a kilogram is larger than grams, meaning that a 2/3 kilograms to 60 grams. So when we are computing ratios, they tell us that to put quantities in the same units. So when they have told us here that larger to smaller, meaning that we are gonna express the quantity of large into that one of smaller. So meaning we are gonna change 2/3 kilograms into grams, becoming 1 kilogram is equaling to 1000 grams, meaning that 2/3 will be 2/3 times 1000 to 60 grams. Taking 3 the other side, then it will become, taking 3 the other side, it will become 2000 to 3 times 60, it will become 180. But by simplifying it to be 200 to 18, if we continue simplifying, it will be 100 to 9, becoming our ratio So let's try to note something. Let's try to note something. Let's try to note something like NB units are omitted when we are competing in ratios, and units are not omitted when we are dealing with rates. So on the answer we got on rates, it was a quarter kilometer per minute, and our answer on ratios is 100 to 9, meaning that ratios don't have units, while rates for them have units. So let's try to look at examples of rates. Let's try to look at more examples on ratios, and we shall take some on rates. So, example. So they say that x place the following ratios. Express the following ratios in simplest form. They tell us ratio number 1, 250 milliliters to 2 liters, and ratio number 2 is 15 degrees to 1.5 right angles. So let's start by number 1. Say solution. They tell us 250 milliliters to 2 liters. If we look here, liters are larger than milliliters, so we are gonna convert 2 liters into milliliters, becoming 1 liter is equaling to 1000 milliliters. So 2 liters will become 2 times 1000 milliliters, becoming 2000 milliliters. So we go and we compare 250 milliliters is equaling to 2000 milliliters. By expressing in ratios, we are gonna omit units, becoming 250 to 2000 by simplifying to become 25 to 200. Also again by simplifying by 25 by 25, so here it will be 1 to 8. So this is the simplest form of at number 1. So let's go to number 2, which is saying 15 degrees to 1.5 right angles. So we are gonna convert 1.5 right angles to degrees, meaning that one right angle is equal to 90 degrees. So 1.5 right angles, it will become, by converting it to improper fraction, it will be 2 times 1, which is 2 plus 1, becoming 3 over 2 times 90 degrees, becoming 45 times 3, becoming 15, becoming 135 degrees. So 15 degrees is equal to 135 degrees by omitting units to be 15 to 135, by simplifying to be by 15 here and by 15 there, to become 1 to 9. So that is the simplest form of number 2. So let's also try to get an example from word problem. A word problem saying that Mariam and Sarah are to share 144 oranges with Mariam getting twice as many oranges as Sarah. And they tell us that to find the number of oranges shared by each. So by our solution, we say that let Sarah's share be x. So, and they said that Mariam gets twice as many oranges as Sarah. So for Mariam's share, will be twice as Sarah, becoming 2x. So by getting their ratios, it will be Sarah's share to Mariam's share, in which Sarah's share is x, and that one of Mariam is 2x, meaning that it's 1 to 2. So they tell us to find all oranges shared by each. So there are two methods. The first, it will be by summing this x's equaling to 144, becoming, let me say, method 1 x plus 2x equaling to 144, getting 3x equaling to 144. So x will be 144 divided by 3, so that will be 4 becoming 48. So Sarah's share is x, which is 48 oranges, and for that one of Mariam's share is 2x, which is 2 times 48, becoming 96 oranges. So if we go to method 2, so this one is gonna deal with what we call ratios. So their ratio was 1 to 2, getting their total ratio to be 1 plus 2, getting 3. And so we start by Sarah's share will be equal to the ratio of Sarah is 1 over the total ratio times the total amount of oranges, which is 144, getting 48 oranges. And for Mariam, is Mariam's ratio is 2 over the total ratio, which is 3, times the total number of oranges, which is 144, getting 96 oranges. So let's also get another last example on that. We say that divide shillings 9,250 among David, Daniel, and Diana. In ratio a half to 2/3 to 3/4 respectively. So it means that the ratio of David to Daniel to Diana is a half to 2/3 to 3/4. So by here we need to simplify these ratios. So for now we are going to find the LCM of the denominators. So by finding the LCM of 2, 3, and 4, it will be 12. LCM is 12. So we are gonna multiply each ratio with the denominator coming a half times 12 to 2/3 times 12 and 3/4 times 12. So we shall get here 6 to here it will be 8, and here it will be 9 as well. Yeah. So it means this is David's ratio, this one for Daniel, and this one is for Diana. So let's divide 920 shillings among them. So let's begin with David. So David, so let's try to find their total ratio. total ratio, it will be 6 plus 8 plus 9, coming, this is the 25 plus the 15 plus 8, which is 13. So this is 17 and 6. This is the 33. So it's a 33. So if we begin with David, it will be David's ratio, which is 6 over 33 times 23. It's 23. It's 23. Times 9, 20, getting change. Getting 23. So 920 divided by 23, I think it's 40 times 6, which is 240 shillings. So on Daniel, it's 8 over 23 times 920, which is a 320 shillings. And we go to Diana, whose ratio is 9 over 23 times 920, getting a 360 shillings. So that is the amount shared by each. So let's go to what we call ratio algebra. In bracket multiple ratio. Bracket multiple ratio. So they can give us this: if x to y is equal to 4 to 3 and y to z is equal to 2 to 1, and they tell us to find x to y to z. So for that comment, we shall get back to you soon. So let's try to finish this and we get back to you. So here we are going to first arrange them like x to y is equal to 4 to 3 and y to z is equal to 2 to 1. So we need to make these y's the same. Y's I need to be made the same. So in order to make them the same, we are going to first find their LCM, which is 3 and 2. Their LCM is 6. LCM of 3 and 2 is 6. So we need to make these y's equaling to 6 because it is their LCM, meaning that x to y and y to z is 4 to 3, 2 to 1. So in order to make 3 to 6, we are going to multiply it by 2, and here to make 3 2 equaling to 6, we are gonna multiply with 3, becoming x y is equaling to 2 times 4, becoming 8, 2 times 3 becoming 6, and also y to z, 3 times 2 getting 6, and 3 times 1 getting 3. So to get x to y to z to be equaling 8 to 6, it will come like this, 8 to 6, and we come here up to 3, getting 8 to 6 to 3, because 6 is the same. So we cannot write it twice. So let's get another example from that. Getting another, they can say if A to B is equal to 3 to 4 and B to C is equal to 1 and 2, they tell us to find A to B to C. Doing the same procedure by arranging them A to B equal to 3 to 4 and B to C equal to 1 to 2, getting the LCM of these B's, it will be 4. It will be 4. So A to B 3 to 4 and B to C equal to 1 to 2. So in order, let me see, LCM of 4 and 1 is 4. So in order to get 4 here, we shall multiply by 1, and in order to get 4 here, we shall multiply by 4, getting A to B equal to 3 to 4 and B to C equaling to 4 to 8. So by getting A to B to C equal to 3 to 4 to 8. So another last example from ratio algebra will be consisting of 3 terms, which will be if W to X to Y is equal to 1 to 2 to 3 and X to Y to Z is equal to 4 to 6 to 7, and they tell us to find W to X to Y to Z. So by doing the same procedure, we do Y to X to Y equal to 1 to 2 to 3, and for X to Y to Z is equal to 4 to 6 to 7. So here we have 2 terms to be made the same, which is X and Y. So we need these 2 terms to be made the same. So by looking at it, we can multiply them by 2 here to make it 4 and 6 here. So it's in order to make X, Y the same. We are going to multiply the upper ratio by 2, becoming x y equal to 2 into 1 to 2 to 3, and that of the downer ratio to be y to z equal to 4 to 6 to 7. By multiplying it through, we shall get w to x to y equaling to 2 to 4 to 6, and the downer ratio of x to y to z equaling to 4 to 6 to 7, getting w x to y to z will be equaling to 2 to 4 to 6 and to 7, the last one. So that's the answer. So after that, we are going to try to look at what we call increasing and decreasing a given ratio. We are going to look at what we call increasing what we call increasing and decreasing in a given ratio. So we are gonna set up by increasing in a given ratio. So they say that to increase a certain quantity, in a ratio of A to B. So they say that A must be greater than B. A must be greater than B, meaning that this new quantity over all the quantity will be equaling to A over B, so long as A is greater than B. So in getting a new quantity, it will be A over B times the old quantity. can be given a simple example from that, which is, let me write it here, which says increase 48 centimeter cubed by ratio of 4 to 3. So here we see that 4 is greater than 3. So we are gonna say that new quantity over old quantity is equaling to 4 over 3, and our new quantity will equal to 4 over 3 times the old quantity. So our new quantity will be equaling to 4 over 3 times our old quantity, which is 48, getting an answer of 1, getting our answer which is 64 centimeter cubed. This is our new quantity when we have increased 48 centimeter cubed. So let's also try to get another. Let's also try to get another example from that. Which will be if radius of a circle is increased, a radius of a circle is increased in a ratio of 4 to 3, what will be the ratio of part A, old circumference, to new circumference, and part B saying old area to new area. So let's solve it from this side. So they have told us the radius of a circle. If we say that if radius of all the circle is r, so the new radius, it will be new radius equaling to a over b times the old radius, becoming a which is a 4 and b which is a 3 times the old radius which is r times r, getting our new radius as 4 over 3 r. So the part A is saying old circumference to new circumference. So old circumference it will be 2 pi r, and that one of new circumference will be 2 pi when we introducing our new radius, becoming 4 over 3 r. So part A is telling us to get the ratio of old circumference to new circumference, getting old circumference is 2 pi r to 2 pi r into 4 over 3 r. So by cancelling out the same to be here to go with this, and r we go with r, remaining 1 to 4 over 3, taking 3 the other side, becoming 3 to 4. That is the ratio of old circumference to new circumference. So we are going to part B of old area to new area. So let's go to part B, saying old area to new area. So old area is pi r squared, and the new area is pi. So if we substitute in the value of new radius, it will be 4/3 r squared. So the value of this old area to new area, getting pi r squared to pi, this one it will become 16/9 r squared, but by cancelling out the same, and r squared will go to this, becoming 1 to 16/9. Get by taking 9 the other side to become 9 to 16. So that is the ratio of old area to new area. After looking at that, we shall try to go on what we call decreasing in a given ratio. Decreasing in a given ratio. So they tell us that to decrease in a ratio of A to B, so A must be less than B. So meaning that then the new quantity over old quantity will be equal to A over B, so long as A is less than B. So in getting new quantity, will be A over B times old quantity, so long as A is less than B. So let's try to get one example from that, which says decrease shillings 6,000 in a ratio 5 to 6. So we see that 5 is less than 6, becoming new quantity equaling to A over B times old quantity. 5 is less than 6, becoming 5 over 6 times the old quantity, which is 6,000, getting 5,000 shillings. So that is the decrease in 6,000 shillings. So finally, we are gonna look at solving problems involving ratios. Solving problems involving ratios, but in this we are gonna look at a ratio method and a unitary method. So let's get an example from that. We see that example. If 12 pence costs shillings 432, so they tell us what is the cost of 21 pence. So by method 1, which is a unitary method, we shall say that 12 pence costs 432 shillings, and so 1 pen will cost 432 divided by 12, and these are shillings, getting 36 shillings. So 21 pence will cost 21 times 36, getting 756 shillings. So let's go on method 2, which is ratio method. First of all, this proportion is under what we call direct proportions. Under direct proportions, but for proportions we are going to study them tomorrow. So they say that this side it will be pence and this one is of costs. They say that 12 pence costs 432. So 21 pence will cost. So let's name these parts. X will cost X shillings, so we need to find the value of X by cross multiplying. We shall see 21 times 4 to equaling to 12 X, getting X as 21 times 432 over 12, getting X as 756 shillings. So 21 pence will cost 756 shillings. So let's try to look at one last example on that. One last example for that. It says that if 5 men, let me see. If 5 men dig a piece of land in 12 days, how long will 15 similar men take to dig the same piece of land. So by method 1, which is unitary method, which is they say that 5 men take 12 days. So 1 man will take 5 times 12 days. Here this statement means that 1 man will take more days than the 5 men to dig that same piece of land. So it means 1 man will take 60 days. So 15 men 15 men will take 60 over 15 days, getting 4 days. So if we go method 2, which is the ratio method, so this is what we call inverse proportions. Tomorrow we are gonna look at them briefly. These are inverse proportions, meaning that 5 men take 12 days, so 15 men will take X days. So by finding the value of X, today we are not going to cross multiply. We are gonna multiply here and here, and we equate them, meaning that it will be 5 times 12 equaling to 15 times X, getting X equaling to 60 over 12, getting 4 days. But for tomorrow, I'm going to take you through proportions and variations briefly, and I try to tell you their concept as well. For today, we are gonna stop here for a bit of time, but please try to like and subscribe to both our YouTube and Facebook channels, and we need your feedbacks as well. Thank you for watching. Express the following in terms of ratios of acute angle, and they have given us one saying sine 150 degrees, and the second one is cos 120 degrees, and the third is tan 160 degrees. So when we are estimating angles, these angles seem to fall in the second quadrant, so the acute angle in the second quadrant was saying to be acute angle in second quadrant was 180 minus theta. So we shall bring our number 1, sine 150 degrees equaling to sine into bracket 180 minus our theta here, becoming sine 30 degrees, and sine of 30 degrees is equaling to 0.5, also equaling to a half.
let's go to number 2, saying that cos 120 degrees, which will be equaling to cos into brackets 180 minus 120 degrees, becoming cos 60, and cos 60 also is the same as 0.5 equaling to a half. And let's try to go to number 3, saying tan 160 being equaling to tan 180 minus 160, becoming tan 20. Here, because it is in the second quadrant, so tan is negative in the second quadrant, becoming negative tan 20, which will be equal to negative 0.3657. So let's try to look at another confusing example. Let's try to look at another confusing example, which will say solve the following equation. When they have given us the range 0 degrees is less or equal to theta, and theta is less or equal to 360 degrees, and they have given us number 1 is cos theta equal to negative 0.5, number 2 say tan theta equaling to negative 1, and number 3 is tan theta equaling to 1. So if we go to our solution, if they said that cos theta is equal to negative 0.5, it means that theta is negative in the second quadrant and the third. So this angle here is expected to be either in the second or third quadrant, which will be cos theta equaling to negative 0.5, and theta alone, it will be cos inverse into brackets 0.5, which is a negative, becoming theta equaling to 60 degrees. But this is the acute angle which is in the first quadrant, but we know that a cos of an angle to be negative, it has either to be in the second or third quadrant. So in the second quadrant, it will be 180 minus theta, becoming 180 minus 60, becoming 120 degrees. So likewise in the third quadrant, it will be it will be theta minus 180, becoming 60 degrees, become minus 180, coming negative 120, and we know that we don't have a negative angle, so cos of a negative 0.5 is only in the second quadrant. So in third quadrant we have got a negative 120, and we know that we don't have a negative angle, so it means theta is 120 degrees. So let's go on number 2, to be tan theta. Tan theta is -1, and we know tan theta to be negative, it's either in the second quadrant or the fourth quadrant. Coming, let's try to find the value of theta. Coming, theta becoming tan inverse -1, coming theta equal to 45 degrees, but we know that tan is negative in the second and fourth, so let's go in the second quadrant, which is equaling to 180 minus theta, be equaling to 180 minus 45, coming 135 degrees. In fourth quadrant, it's 360 minus theta, equal to 360 minus 45, equaling to 315 degrees. So let's go on number 3. Which will be into tan theta equal to 1. We know that tan theta is only positive in first and third quadrant. Let's try to find the value of theta, becoming theta tan inverse 1, theta becoming 45 degrees. So theta is only positive in first and third, so this is the first quadrant, and third quadrant is theta minus 180, becoming 45 minus 180, which is a negative 135 degrees, which is impossible to have a negative angle, so it means theta is 45 degrees in the first quadrant. Let's also try to look at another confusing example. Which is given that sine A is equaling to 3/5 is obtuse. Find the value of tan A. They have told us that sine A is equal to 3 over 5 and A is obtuse. So let's try to locate sine A in the Cartesian plane, which is the y-axis. So I'm carrying the x-axis, and we draw our unit circle like this. They have told us that A is obtuse, so meaning it is in the second quadrant between 90 degrees and 180, so it will be here. This is A, and sine is opposite over hypotenuse, so this one will be 3 and this one 5. So let's name this downer part x. So let's try to find x. Applying Pythagoras theorem, it will be, let me say, applying Pythagoras theorem, we shall find the value of x as 5 squared is equaling to 3 squared plus x squared, becoming 25 equaling to 9 plus x squared. To get x alone to be x squared equaling to 25 minus 9, x squared equaling to 16. Getting x alone, we are gonna square 16, becoming x equaling to 4. So our x is equaling to 4. And to find tan theta, we know that tan theta is equal to opposite over adjacent. So tan A will be equal to opposite, which is 3, and the adjacent, which is equal to 4. So this is the value of tan A. And a last example on quadrants will look like this. Look like this. If 180 degrees is less or equal to x and x is less or equal to 360, and that cos x is equaling to negative 5 over 13, find sine x and tan x. So let's sketch our Cartesian plane like this. This is the y-axis, and this one, which is the x-axis, and we draw our unit circle. They have told us that if 180 degrees is less or equal to 360. So meaning that they are meaning this region down here, 180 and 360. This is 270 and this is 90 degrees. They want this region here, and they have given us a negative cos, meaning that negative cos is only found in the third quadrant. In the fourth, it is positive. So our point X will be here. And this is our X. So cos is adjacent, which is -5, over hypotenuse, which is 13, and they have told us to find sine X over sine X and tan X. So we need to find the opposite. So let's name it Y, applying also Pythagoras. It will be hypotenuse, which is 13 squared, equal to adjacent, which is -5 squared plus y squared, equal to 169.25 plus y squared, and getting y to be y squared equal to 169 minus 25, y squared equal to 144. Getting y alone be a square root of 144, y equal to 12. So y is on the negative side of y-axis, so it's gonna be also a -12 because it is on the negative side of y-axis. So they have told us to get sine X being equaling to opposite over hypotenuse. So our opposite is -12 over our hypotenuse, which is 13, and our tan X is equal to opposite over adjacent, and our opposite is -12 over adjacent, which is -5, becoming these negatives will cancel, becoming a +12 over a +5. So this is our value of tan X and the value of sine X also here. After doing that, we have completed on what we call a right angled triangle. So we are going on what we call a non-right angled triangle. Non-right angled triangle. In a non-right angled triangle, there is no an angle which will be equal to 90 degrees. So by saying this, it will be like this: A, B, C. This side will reflect B. This one A, and this one also C. But these angles will be adding up to 180, but you won't find any angle inside here equaling to 90 degrees. So it may be 30 here and a 60 here. No 60. It may be like also a 30 here. So here it will be something like 120 degrees, and when you sum them up, you will get 180 degrees. So in non-right angled triangle, we are gonna look on what we call sine rule. So in non-right angled triangle, the what we call isograph, and this sine ratio, cosine ratio, and also tan ratio won't work in a non-right angle. For these ones, deal only in right angled triangle. Only in right angled triangle. Apart from that, nowhere else you will use them. So in non-right angled triangle, we shall find what we call a sine rule, and this sine rule suggests like this: A over sine A equaling to B over sine B, and C equaling to sine C. i.e., if we draw our triangle like this, naming this angle A, this angle B, and this one C, this one will be A, this one will become B, and this one C. So C over sine of C, and A over sine of A, and B over sine of B. So let's try to get an example from the sine rule. It will be like given a triangle A, B, C, in which C is equaling to 4.85 centimeter, angle B equaling to 30 degrees, angle A equaling to 70 6 degrees, and they tell us to find angle C, and another one they tell us to find side B, another side A. If we draw our triangle like this, then this one has A, B, C. They have told us that angle B is 30 degrees and angle A is 76 degrees. So angle C is unknown, but they have given us side C, which is down here. Side C, which is 4.85 centimeter. And the first question is saying to find angle C to be equaling to 76 degrees plus 30 degrees plus C equal to 180 degrees, becoming is it 70? Yeah, it's 76, becoming 106 degrees plus C equal to 180 degrees. C equal to 180 minus 106 degrees. C equaling to 74 degrees. So our C here is 74 degrees. They have told us to find side B, which is here, side B, and by applying sine rule, it will be like this: A over sine A equaling to B over sine B, and C equaling to sine C. So we are gonna take these two. These two here, and we become part 2 to B. B is unknown, which is B over sine 30 equal to C, which is 4.85 over the angle of C, which is sine 74. In getting B, will be going to be equaling to 4.485 times sine 30 over sine 74. B equaling to 4.85 times on what called, let me see, which is 0.5 over the sine of 75 equaling to 0.9511. B equaling to 2.7023 centimeter. So let's go to part 3 of the question to find side A. We can choose A over sine A equaling to C over sine C, whatever you want. But now we are gonna take A over sine A equaling to C over sine C equaling to A over sine 76 equaling to C, which is 4.85 over sine 74. So A will be equaling to 4.85 times sine 76 over sine 74 equaling to A 4.85 times 0.973 over 0.9511 equaling to 4.947 centimeters. So B is equal to 2.702 and A is equaling to 4.947 centimeters. So let's try to look at what we call the cosine rule. On the cosine rule, it states like that. Cosine rule states like this. That A squared is equaling to B squared plus C squared minus 2BC cos A, and B squared equaling to A squared plus C squared minus 2AC cos B, and C squared is equal to A squared plus B squared minus 2AB cos C. So when you need to find cos A alone, it will be like cos A equaling to it will be equaling to B squared plus C squared minus A squared over 2BC. Someone there may wonder how this one comes about, but it's all algebraic format. It will be like this: A squared equaling to B squared plus C squared minus 2BC cos A. So we take the whole of this term, this side, becoming A squared plus 2BC cos A equaling to B squared plus C squared. So we take A the other side, becoming 2BC cos a equaling to b squared plus c squared minus a squared. In remaining with cos a, we are gonna divide by 2bc, and here 2bc becoming cos a equaling to b squared plus c squared minus a squared over 2bc. The same here. Getting a alone to be cos inverse into brackets b squared plus c squared minus a squared over 2bc. In getting a alone, so let's look at one example from the cosine rule, and we go on what we call the area of a triangle. This example here is like this. In a triangle ABC, A is equaling to 130 degrees, B equaling to 4 centimeters, and C equaling to 5 centimeters. Find length of A. This is part 1. They have told us to find the length of A, and part 2 they are saying angle C. Part 3 saying angle B. Applying our cosine rule, we shall take the first one here, which is the first one, which will be, this is part 1, a squared equaling to b squared plus c squared minus 2bc cos a squared equaling to they have given us b equaling to 4, which is 4 squared plus c equaling to 5 minus 2 times 4 times 5 cos they have given us the angle of A equaling to 130 cos 130 degrees. So A squared will be equal to 16 plus 25, which is minus, not, is minus 20, let me see, 2 times 4, which is 8 times, which is 40, and cos of 130 will be equal to 0.4. It is 0.6428, and when we solve it, will be a squared equaling to 16 plus 25 equaling to 41 minus 40 times 0.6428 equaling to 25.6 71. So a squared will be equal to a squared. Let me see. It's a negative here. So a squared will, if we subtract, we shall get something like 41 minus 25 to 6. It will be like 5 point. Let me see, 5.29 by applying a square root on 5.29, it will be 2.241, which is your side. So let's try to go on part B. Let's go on part B to find angle C. Angle C. So in finding angle C, we are gonna try to use the formula here, which we are gonna apply direct and substituting A in form of C. So here it will be C, and also it will be C, and here becoming A, C, A. So it's gonna be angle C to be equaling to cos inverse into brackets, which is b squared plus a squared minus c squared over 2ab applying the figures to be cos inverse into brackets. B is 4 squared plus a which is 2.241 squared minus c, which is 5 squared over 2 times a, which is 2.241 times b, which is 4. Let's complete it from here. So angle C will be equaling to cos inverse into brackets 16 plus 5.29 minus 25 over 2 times 2.241 times 4 equaling to cos inverse into brackets. If we sum them up, we shall get something like, we shall get something like 57.6 7489 over 65.36, coming a cos inverse of 0.8836, getting a 27.96 degrees. This is our angle C, and they have told us to find angle A. Angle A, we are gonna check angle B. We are not gonna waste a lot of time there. We shall use a knowledge of sum of all interior angles of a triangle add up to 180, which will be A plus B plus C is equal to 180 degrees. So A, it was 130 plus B plus C, which is 27.96 degrees, equal to 180. So it will be B plus 157.96 equal to 180. B will be equal to 180 minus 157.96. B equaling to 22.04 degrees. So after this, we are gonna look on what we call the area of the triangle. Area of triangle. So let's have our triangle like this. Which is this one A, B, C. This side will reflect B, this one A, and this one C. So we have our height as H, and it meets the base at point D. So from our primary, we know that area of a triangle is a half times base times height. So area is equal to a half times the base, which is C, times height, which is H. So let's name this equation 1. So let's try to consider triangle A, B, C, which is here, and let me try to sketch it. It's here like this. This is A, D, and C. this one is H, and this one is B. So here this is sine angle A. So here we can see that we have gotten what we call the opposite and the hypotenuse, and a sine ratio which deals with the opposite and the hypotenuse is the one which is called sine of theta, which is A equaling to opposite, which is H, over the hypotenuse, which is B. On getting H alone, it will be H equaling to B sine A. Let's also try to consider triangle. Let's also try to consider a triangle DBC, which it looks like this. This part is D, and this one is B, and this one is C. So also here we have H, and this is A. So if we find sine B will be equaling to opposite, which is H, over the hypotenuse, which is A. In finding H alone, it will be A sine B. So we are going to use these different values of H here, and the same here, to substitute in the value of H in equation 1, which is to substitute in equation 1. So it will be A equaling to a half C into brackets B sine A, when we substitute in the value of H, becoming area equaling to a half B C sine A, being equation to the same area equaling to a half AC sine B, when we substitute in the value of H here, becoming AC sine B. The same also becoming area equaling to a half AB sine C, as well becoming equation 4. So let's try to get an example here. Which will say in a triangle A, B, C. A is equaling to B and B is equaling to C and C is equaling to 10 centimeter. Find the area of triangle ABC. So let's try to sketch it like this. It will be which will be A, B, C. They said that these sides are all equal and they are equal to 10 centimeters. So it means here it will be 10 centimeter, 10 centimeter, and 10 centimeter. And a triangle which sides are equal, so it means it's called an isosceles triangle, meaning that its angles are 60 degrees because sides are the same, so angles will be 60 degrees. And they have told us to find the angle, the area of a triangle. So let's choose any of these formulas. So let's take the one here, which will be area equal to a half BC sine A, coming a half times 10 sine 60 degrees, which will be 5 times 10 and the sine of 60 is 0.8660, getting the answer as 43.3 centimeter. So this is our area here. So let's look at what we call the Helonius formula. Helonius formula. It's also used to solve the area of the triangle as well. It's called Helonius formula. So let's have our triangle like this. This one becoming A, this one B, C. So this one will reflect B, this one will reflect A, and this one C. So it states like this: area of a triangle is equaling into root S into brackets S minus A, to brackets S minus B, to brackets S minus C. So, and to find S is equaling to a half a perimeter of triangle ABC, which is a half into brackets A plus B plus C, which is the perimeter of the triangle. So let's try to look at an example on Hellonis formula, which we are gonna use the same example we used last time. We are not gonna change anything. So let's start by finding the value of s, which is s equaling to a half into brackets a plus b plus c, becoming s a half into brackets 10 plus 10 plus 10, becoming s into a half times 30, s becoming 15. So by applying Hellonis formula of finding the area, we shall see that a is equaling into s into s minus a into s minus b into s minus c, coming into brackets s is 15 into brackets s 15 minus a, which is 10, into brackets s is 15 also minus b, which is 10, and s is also 15 minus c, which is 10, coming 15 times 5 times 5 times 5, coming root into 1875, getting the same answer as 43.3 centimeters squared as the last, as we got last time when we used the other formula of area equaling to ABC sine A. So by doing this, we are in quotation of finding area of any triangle. And for today, we are gonna set up here, and this marks the end of trigonometry. And next time we shall try to look at another topic. We shall inform you about that. So for today, we have stopped here.